So you should keep your mind when you are using Facebook information. Is there anyone who are dealing with the Facebook data here? I think we have the Twitter, some of the Twitter data. So it doesn't matter. First time I'm thinking all the project should use the art programming, but if you want to use the other API or the other programming, during the proposal, you need to present, then based on this question, with my approval, you can use it. But even though you are going to use the other API, other programming interface, IDE, but you need to register. Twitter is pretty much the same, so you need to get the token to access the data, but you can download the many tweets, right? So is there any daily limitation or the?
No, not daily limitation. They just give you that streaming API. Just give you like a certain percentage that their claim that it represents the whole sample.
Also, if you want to again use such accessing the social media data using the iPhone, it's pretty much simple. So you can test with the exercise lab document. But I tested several times. It works, but I cannot guarantee it works forever. So in case you find any problem or you encounter any problem, let me know. Okay, I will fix. Okay. When I used R programming a couple of years ago, first time, there's no limitation to access a Facebook message, so I can actually download as much as possible. So even I can build a very nice the graph, the structure for my friend. So you can. It was very nice. I think that if you visit my Facebook page, a couple of years ago, I upload the output of the Facebook, but but nowadays it's limited. And I think also I ask you to create a video that capture your project video, but don't be stressful a lot. I just wanna see how you guys are involved and how you guys work. If you communicate through the Messenger or something Google Docs, so you can take the capture or the video shot for such the screen or whatever, anything is possible. 10 minutes is too long. I realize that. It's even couple of minutes, as long as that video can describe what you have done so far, it's okay. Okay, try to think about such a the video shot. And also, I didn't mention about another requirement of this project, but I'd like to give up. The thing I thought at the beginning of the semester was for the problem definition. So each team has some problem definition, what you are going to analyze. For that, the problem, I'd like to ask actually at least one the topic for public, okay? Which means it's not for the commercial purpose or the advertisement, for public. Okay, but I gave up, so it's too late, so it's up to you. But why don't you think about nowadays, because of due to the characteristic of the big data, there might be some group or company who own the most of the data, like the Facebook or Google. Okay, and what about the small company or public? Okay, sometimes we need the analyzed data. Okay, mine the data. Okay, for the low income. Okay, when they decide whether my children can go to the college, there are a lot of the family group who never send their children to the college. Okay, in United States also. So is there any the data analysis that can contribute on the public? Okay, so that will be that can be another objective of this one, but I forgot to mention about it, and that should be based on the kind of discussion. So I will not first you guys to think about, to consider this, but why don't you, if possible, depending on the project title or topic, why don't you think about whether your data mining result can contribute on the public, especially underrepresented group or the low income family. Okay, so that is very important. That will be the important issue. So mostly most of the big data analysis or the data mining focus on the commercial purpose, like the marketing or something like that. But we can consider also the public issue when we analyze the data. That makes sense because many of the data sources are from the public data sources like the government. It's free, everybody can access, but those who can analyze, use such a data, it's not on the low income or minority. It's usually those who has the money or the power or the customer, they can actually handle such a data. That's kind of the problem. Okay.
Professor?
Yes.
How about the pattern evaluation for this phase? Now, we are just doing proposal for the project. So what are you expecting from us?
So in your proposal, that is also an important part. How are you going to evaluate your output of the data analytics? Okay, think about it. So we are going to use. We will discuss some possible ways to evaluation for the evaluation, but we don't have to stick on the such a, for example, 10 cross validation or whatever. But you guys need to think about how to evaluate. That's also one important
So just initial
part.
idea how to...
Yeah, that's just the idea, yeah. Okay? So we have talked about the information gain. So gain ratio is because the information gain, rely on the attribute with a large number of values. That means, so this is information, expected information need for the specific attribute A, and this is information gain. However, if we have huge amount of the data, okay, why don't you think about the large number of D? That means, okay, it's a smaller number, then the information gain will be higher. So it bias to the number of the data. So can we address such a problem? At that time, usually we can imagine the solution. What can be the solution? Normalize ratio. So we can consider such a ratio, which means that we can apply the total number of the data set. Okay, so nothing but the gain ratio. So based on ratio. Instead of the subtraction, we can consider the gain ratio of A. So gain A divided by the split info. So if this one is smaller, this one will be higher. Okay, smaller means it's a high purity. Okay, then we can select such a data, such an attribute. That is called usually C4.5. I don't know why. There might be a reason. I knew that by Torah, but usually it's called the C4.5. The previous one, the traditional one, is the ID3. And this one is called the C4.5. Nowadays, not many the paper compare their approach with this one, but when I was a student, whenever I read the paper, most of the data mining technique, they compare their approach with this one or ID3. So it's kind of the reference. The next one is the Gini index. So sometimes it's called the CAIT card. Okay. At this time, okay, this one is kind of the this one is a probability of the frequency. It's a probability. Okay, it's based on the frequency in total data set. So why don't you think about the extreme case? So oh yes, which means probability is 1 and Gini index will be 0. Okay? Otherwise, if that is the scatter, like the 1 over 10, 1 over 10, so 1 over 10 and square is 1 over 100 minus is the point something. Okay? And so we can have the such a the Gini index value. So we can define the attribute that can minimize, okay, the such a difference. Okay? That is the difference. It's quite similar, but anyway, so that makes sense if we think about. So that is another one. Okay, so this is a comparison. This slide shows a comparison among the information gain. But as we have seen, the multi-valued attribute is a bias. It's a stick to the such a multi-valued attribute. And gain ratio, it prefer the unbalanced data. Okay, so because it's a ratio. Ratio means so it doesn't matter how many of them. It's so 90% or 10%. Okay, something like that. So it's it's a prefer such an unbalanced data. Okay. There are the many more the decision tree based algorithm classifier. So among them, I have focused on the MDL, the minimal description length, but nowadays not many people are using because of the powerful the classifier that we are going to see the next week. That is SVM, but the MDI is one of the interesting one. Okay. There are some problems in the decision tree. So one is overfitting. Overfitting will be usually happen in the iterative or recursive algorithm in machine learning or data mining. It tries to fit to the objective function too much, so it will be too details of the rule like the branch. Okay, so overall, as we have seen the disadvantage the characteristic of the decision tree is a greedy algorithm. Try to focus on the local optima, then try to find the attribute value that can provide the higher information gain for them. So too much hard to understand. So what is the meaning of the rule of this one? This is called overfitting. Okay. So how can you address problem overfitting? We can stop at a certain time. Okay? Or after we build such a tree, prune out some of the meaningless, the branch. Okay, that is the pre-pruning and the post-pruning. At that time, for the pre-pruning, we should have the something stop the condition when we are going to stop. Otherwise, it will stop no class or the clearly classified or the no attribute. That is a stop condition, but we can add more stop condition for the pre-pruning and post-pruning. So after we got this one, so what if we take out this one, whether we can have the better the classifier one. Okay. Also, it has the some of the approach try to address the problem of the continuous value. So most popular way is before we start to run the decision tree, we try to change it, the attribute, the continuous attribute to the categorical value, something like that. Okay. Nowadays, another problem is how to handle the large data or big data. So there are approaches to address this kind of problem. For example, the ABC set, I never used, I didn't pay attention too much for this one, but I believe there's such a scalability, or the handling big data or the huge amount of data in classifier is very important nowadays. So that will be one good topic those who are interested on the decision tree. Okay. There are using the tool for the classification. So it provides a nice graphical user interface because it provides the tree structure as the output. I have one example. Okay. I just got this one from just a simple Google search. I do not have any experience. I'd like to show just one of the example of the decision tree tool. Okay. So for example, tree. So you can select the train data. So I'd like to use the DNA data. And for the test data set, DNA test, and some class free exists the classifier, DNA train. Okay, so I just use the default setting. You can see some such a hard to see. Something the output is tree structure by applying the algorithm. Okay, if you are interested, just search the Google something decision tree application what I did with. Even you can use the Wake-up. Okay, Wake-up provide the most of the popular the decision tree algorithm, so you can test it. And the next one is the Bayesian. I tried my best to finish this chapter today. We have much more slide. Okay, so this is a base. First, you need to understand what is a Bayes theorem or the Bayesian rule. Okay, what is a Bayesian rule or Bayesian theorem? I think that you learned in your high school math.
This is
It's a conditional probability. Why don't you take a look at this one? Okay, first this. Okay, so this is a conditional probability. So given y, the probability of x. So that means this is a x, this is a y. Okay, so I'd like to find the probability of x given y. Okay, this part for the x at that time. So that is the conditional probability. This means x and y based on y. So that is x probability of x and y of given y. So based on given y, what is the probability of this one? That is the conditional probability. Or vice versa. So what is the probability of y, okay, given x? Then the probability of x and y is this one. Even definitely this one from the this. So you can move this is the multiplication probability of y given x times the probability of x. Okay, that is this one. Okay, then apply this one to the here, so we can get the probability of x given y. Okay, we can find the probability given y. How? If we know probability of the y of given x, this one. If we know the probability of this given x, then px and py we already know, right? So that is the base rule. Okay? So we don't have to know directly this one. If we want to know the probability of x and y for the x, we can calculate, okay, using p of x, p of y are given. Okay, we already know. Then if we know that this x and y based on y, we can find the probability of x, the probability of this one given x. Okay, so that is the base rule. How can we use this one for the classification and prediction? So until this one, everybody can understand. This is what we have learned in the high school math in statistics part. But here, let's say the H is a hypothesis. In other words, simplify the problem. So positive or negative for the breast cancer case. So class is the buying computer, for example. Buying computer, yes. Buying computer, H1 is the yes. H2 is no, for example. Okay, this is a hypothesis. We'd like to test that hypothesis. So this is a hypothesis we'd like to test. So H, the based on X means this is based on this one, based on the Bayesian rule. This is X base given H. Okay, then P of H, P of X. This is called posterior probability. Then what does that mean? P of H. What is the P of the yes? Probability of yes. It's 1/3, 2/3, something like that. So we can easily compute this one. And probability of X. This is also given. We know that probability of the X. Then if we know that this one X given by probability of X for yes, among the yes, among the people who buy the computer, okay, we can find the probability of X. If we know that this one, in case there is the new data, for a given new data, we can decide H1 yes or no. That is the idea of the Bayesian classifier. Okay, so in this case, H1 over X, H2 over X definitely is the 1. That is the axiom of the probability that we have learned at the beginning of the semester. Okay, so 1. So for example, H1, buying computer is the 80%, buying the, not buying the computer, let's say the 20%. Okay, for example. Then, if we have a new data, new customer, okay, X, so new customer, whether this customer buy the computer or not. So we can use this one. To simplify the problem, we will use, okay, we will use this one. Let's say the H1 is, H2 is higher. So let's say H2, why don't you change? In this case, it's 20%, 80%. I think I made a mistake. Okay, why don't you change it? Okay, then the H1 is H2 over the given X is higher than H1, which means the not buying computer is higher probability than the buying computer. At that time, we can modify this using Bayesian rule. Bayesian rule is here, this one or this one. So it will be the Bayesian rule. Then we can actually remove the denominator, P over X. So we will get this one. Then we can have this equation. This one means the right hand side P over H2 over P over H1. What is that? We can decide. There is a fixed value. It's already exists based on training data. It's a threshold value, right hand side. And this one is X over the given H1, X over H2 is the likelihood. Likelihood means we can guess, compute the close to that classifier, that probability. So we can use the log likelihood, maximum likelihood. This is another likelihood to calculate, to evaluate the hypothesis. So that means if this part is bigger, means that is H1 will be selected by computer. If the less than threshold value, which means the not by computer, no, will be selected. So H1 will be selected in case it's bigger than the threshold value, and otherwise the H2 will be selected. So left hand side is called the likelihood ratio, and right hand side is called the threshold. Let's see the example of the using Bayesian theorem. So let's say the 80% of the mail is a spam mail. We know, we train, we learn. Okay? Then our hypothesis, our classifier, our goal is H1 is a clean mail, H2 is a spam mail. What is the probability of H1? 20%. 0.2. What is the probability of H2? 80%. So threshold value according to this one, P over H2, the over P of the H1. Okay, that is 0.8 over 0.2. That is a 4. So 4 is threshold value. So if the left hand side, the likelihood ratio is bigger than 4, that means H1 will be selected. What is the H1? It's a clean mail. Otherwise, it's a spam mail. Okay, how can we compute the log likelihood? The likelihood is we can just apply this one, the conditional probability. So conditional probability H1 in the H1. So let's say the incoming mail is include the biograph. Okay. In case of biograph, when we check the training data set, so that is the probability of the mail that include the biograph from the clean mail, that is a Px given H1. And the probability of the spam mail of the X that include the biograph is the Px, the P of X given H2. So we can, for example, from the training set, not for the incoming set, from the training data, we realize 10% of the clean mail include the biograph. Okay? And 60% of the spam mail include the biograph. So we have this data. So 0.1 over 0.6 is the likelihood. So 0.1 over 0.6 is 1 over 6 is less than 4, which means this, what is the less than this? Less than this means the spam mail. So this is called the exit. This email is the spam mail. You can classify. Okay? That is based on the Bayesian rule. Okay? So we are going to use the for classifier. Okay? So how can this is the Bayes theorem. Okay? So a hypothesis, in other words, class that we are going to determine. For a given data, incoming data, that can be determined by the posterior, the probability. P of X, P of H, we already know. Okay? We can easily calculate. Okay? At that time, to apply for the classification, this is a Bayes theorem. Okay? Actually, this kind of question is kind of math competition for the high school or the freshman level of the college student. It's a math competition question. It's not very complicated. So we try to apply this Bayesian theorem for the Bayesian classifier. We try to apply to the classification algorithm. To do that, first we define the x. Instead of the incoming data x, it has the x1 through xn attribute, like this one. Age, the gender, or the name, or the something like that. So that is the attribute, x1 through the xn. Then C1, C2, Cm is a class. In this case, two classes, yes or no, one positive or negative. Sometimes it can be multiple classes. So that is C1 through Cn. Then we try to determine for the incoming data x, what is the highest probability to belong to the class. In case of the binary, the class is a positive or negative. Or for example, the mass 1, mass 2, mass 3, mass 4, what is the highest probability? Then we can assign to them. How can you find this one, highest probability? We can apply the Bayesian theorem. That is, we know the P of C1, P of C2, P of C3, and P of X is a constant value. We already know. This one is called the posterior. Posteriori, the probability is for a given class. What is the probability of the training data? Is the data. Okay. How can we calculate this part? Okay. Actually, how can you calculate? So this part, the posterior probability, can be the product of each the attribute. Actually, it doesn't make sense. Why? Because each attribute should be maybe sometimes related. However, we are to simplify the problem, we are going to consider each of x1, x2, x3, xn. Age, the age, gender, name, address, they are independent. We assume. That is the reason it's called the naive Bayesian. It's a simplified Bayesian, the classifier. So because of that assumption, we can multiply to calculate this one, the probability of x for each the class. We can multiply. We can product because each class C1, C2, Cn, the yes or no, this one, the attribute by attribute, they are independent. Okay, that is actually assumption. Okay. Oh, no. Attribute, yes. So for attribute is independent for Ci class. Okay. Then for the continuous value, it is a categorical data, but in case of continuous value, we can use the Gaussian distribution. Okay, Gaussian distribution because it's the most frequently happen in the middle. It's rarely happen, so it performs the Gaussian distribution. So we can use such a Gaussian distribution to represent the P of the xk for the given classes. Okay, so at that time we can represent the Gaussian distribution with the mu, the mean value, average, and the variance with each attribute. Okay, so this is the Gaussian. Then we can apply the same the Bayesian rule that we have discussed before. This one is the likelihood, and this one is we will move this one to here, this one to here. Then it will be the left hand side the likelihood, right hand side the threshold value. Then we can determine the class for the input data. So this the Bayesian classifier, actually naive Bayesian. The reason why we call the naive Bayesian is we assume this part, each attribute, each other is independent. So that can be drawback, disadvantage of. It's very hard, almost impossible to find the attribute that each of them are independent. Okay, so that is even though it has something. So how to predict? We using the same. This one we try to pick up the highest probability. Okay, then we can decide. So it's not a big issue. So this is the same slide. Okay. So in this case, so for example, we have the two class for the problem. Yes or no, buying computer, not buying computer. Then this is the incoming data, the new customer. So we'd like to decide whether this customer will buy the computer or not. Using decision tree, it's easy, we can follow the rule. But using Nalive version, we'd like to utilize the conditional probability based on the attribute. Okay? Then determine. How can we do that? So for example, P of the probability of the yes buying computer is 0.6 something, and the not buying computer is 0.3 something. Okay, then we should have the this one. We need to compute the probability of X per the class. Okay, we need to compute this one for each class. So what kind of attribute? Age for age, and the next income, next student, next credit rating. Okay, then for example, and then per classes. So we have the two classes given yes or no, yes or no, yes or no. So we will compute based on the training data. We can compute this one. Then, as we have seen before, we assume that each of them are independent. So we can just product of the yes. So 0.222 times 0.444 times 0.667 and times the 0.667, that is 0.044. Similarly, we product the no class, okay, then 0.0019. Then finally we can multiply the probability of each class, that is the 64 to this one, 352.019. Then this is the probability. Then we can say this one is a higher probability, yes. Okay, then this we can assume, we can predict this customer will buy computer. Okay, how can we use this one for the real case? What about the Netflix? Netflix, we need to determine the attribute to represent a customer. Or we have the 100 number of the movie. Okay, so and 1,000 of the customer information. So customer 1 watch movie 1, movie 10, movie 99. Okay, and customer 2 watch this. Customer 3 watch this. Then we have the new customer. Okay, who has watched this one. Whether this customer watch for example, which one is the latest movie? Cinderella. So based on that previous the experience, so we'd like to determine the highest growth, either this one or this. Or you can use the class, the problem as the movie, 1, movie 2. You can select the best one of the best one. It's a recommendation system which is very popular. Which still the Netflix use the same approach to recommend the movie. Okay? So that is the Nalive-based classifier. One of the problems of the Bayesian approach is, as we have seen here, is a product of the probability. What if? 0. The product of this one will be 0. That's a problem. So to address that one, it's called the Laplacian correction. We give minimum, okay, minimum product to avoid the 0, the probability problem, the minimum value. Okay. Advantage is easy to implement. That is the reason. So many of the researchers use the Nalive version. Even real production system use the Nalive version, the classifier, and it's a relatively good result compared to other. Okay, in most of cases also. Problem, as we assumed before, is independence, which is not possible in real case. Like for example, in case of a movie, the movie 1, movie 2 may be relative, right? The movie 2 and movie 3 may be relative. There might be. So ideally, it's not possible. Ideal case. Okay? There is practically the dependency to this. But still, navigation provides a reasonable result, so that can be used for the reference source. So which means if you have the new, or the modified enhanced classifier, you can compare with the result of the navigation. I know there exists a lot of the library and program, but if you want to implement the navigation, if you want to use the navigation or the existing algorithm, please try to at least understand how they are implementing that algorithm. Sometimes I have seen many of the code, they slightly modify. Okay, they assume, because it's the practical application. It's not the research purpose. So they slightly modify or they give the assumption or they give the condition to make the better accuracy. Or sometimes the adjust, okay, or the manipulate the output. So be careful when you are using the existing library. If that is not the evaluative, you'd better use your own code. I'm going to skip the rule-based the classification. It's based on the if-then-else, basically. But first, to classify the data, we need to go through entire data set, training data set. What if training data set is so big? It takes up time. Is there any way to make the rule the real time? That is the idea of the rule extraction. And not rule extraction, it's a sequential covering algorithm. Okay, so we try to find by accessing the training data, we try to find the rule as a real time. So, for example, we find such a rule, it's a positive, negative, so 2/3, 60%, but we give the more the condition or assumption or the restriction. Then try to make the better quality of the result. So then finally we can select that one as the rule. Okay, so we have seen the three, including the rule-based classification. We have seen the three different types of the classification. Next week we will see the more advanced, including the support vector machine. Okay, but we need to evaluate. I think one of the students asked the question how to evaluate. So we need to evaluate the model or classifier or result of the classification. So how can we do that? There are different types of the evaluation. One is a hold-up method, cross-validation, and bootstrap. We will see. Before that, this is called the confusion matrix. Many of the PhD students may be familiar with this one. So this is the extra class. True, positive, or negative. Or positive, not positive. True or false. Okay? So something like that. And this is a predicate. My classifier, the predicate. This one is the C1 is the true, and C2 is the negative. So if you correctly detect the true as the true, that is the true positive. If you correctly detect false as the false, negative as a negative, that is true negative. Don't be confused. True means correct. True positive means it's a correctly detect the positive one. True negative means correctly detect the negative case. Then this one is a false case. False negative means it's supposed to be the false, but it's a false. So false negative. It is detected as the true. No, opposite. So it's supposed to be true, but it is detected as the negative. So it's a false negative. Negative, but it's incorrect. So this one is a positive, but it's a incorrect. False positive. So don't be confused. Still, I'm confused with this one.
It's a confusion matrix.
So this one is correct, incorrect. Okay? This one positive and negative. Negative is detected as. Okay? So false negative means it's detected as a negative, but that is incorrect. Which means that should be supposed to be the positive. Okay? Something like that. This is a real example. So this is a true. How many people are buying the computer? Okay? So 7,000. Okay? So 7,000. And 3,000 not buying. So we have the 10,000 the training data. So testing data. Then my classifier detect 6,954 as the yes, which means correct. And 2,588 is the correctly detected for not buying computer. But this one's supposed to be the yes, but detected as the not buying computer. And this one, vice versa. Okay? It's supposed to be the false, not buying computer, but detected as this one. Okay? So at this time, so this is a summary of the confusing matrix before. Okay? True positive, true negative, false positive. So accuracy is correct. True means correct. TP plus TN, right? Over all the data. This is the general accuracy that you know and that I know. Okay, that is the general accuracy. Error rate is the subtract from 1 or false. P false, negative from all. However, that cannot represent real accuracy in case of what? Unbalanced data. Like the 99% of the positive and negative, and only 1% or less than 1% the positive, like the cancer. Cancer is relevant. For example, Ebola. Okay, so that is the unbalanced or HIV cases. At that time, we can consider sensitivity. Sensitivity means it's among the positive, it's real the data. It's not detected data. Among the real data, how many of them are correctly detected? That is a sensitivity. And the specificity means, so this one, among the negative case, like the not buying computer, how many of them are detected? That is a specificity. So many of the researchers that deal with the unbalanced data, which is general. Okay, there are not much data sets happening. Okay, at the time they consider sensitivity and specificity. Okay, which means accuracy by the class. I don't know why name is as a sensitivity and the specificity for the negative case, but anyway, so it's for each class. So that is. Also, another thing is, for example, the extreme case. So we have the only one, the Ebola case, and the other, the 24 student. We have 25 students, only one Ebola cases. So my classifier detect all of them are negative. Okay. Then, in terms of the in terms of the specific sensitivity, so it's a 24, 25. This is the 24. It's a 24. So correctly detect 24, and this one, it's a 1. Okay. So false, negative, 5. So I detect the 24, 1, and 25, 0, 0. Okay? My classifier determine 24, 1, and 25. Actually, this is a 24, and this one is 1. Okay? So in terms of the sensitivity, so 0, 0. In terms of sensitivity, it's 100. However, in terms of the specificity, it's at 0. Okay? So, however, we can use the different way to represent that one. It's a precision. Precision means my algorithm detect this as the 3 as the positive case of the Ebola. Okay, for example. Then I detect all 100% real positive case, the Ebola case. So it's 100% in terms of the specificity. But if I detect the 25 all the student positive, it's still the 100% specificity. Then we'd like to determine how much precise my algorithm is. How much precise? Among 25 detected, how many of them are real? So 1. Precision is 1 over 25. And recall, it means really how many of them you detect. 1 out of 1 is